Okay, we are factoring perfect square trinomials. It's from section 8.9. For perfect square trinomials, it has to be a perfect square on the A and the C, which these are. It should always be a plus on the second spot. I think that was supposed to be, so let's go make that a plus. The middle term has to be the square root of this times the square root of this times 2. So m times 3 times 2 is 6m. So this is a perfect square trinomial. So the answer when we factor is going to be the square of the first, the square of the last, a subtraction in the middle if that's subtraction, and squared. Perfect square, perfect square. The square root of the first one is r. The square root of the last one is 2. R times 2 is 2r times 2 is 4r. So that works. Square root of the first, square root of the last. This times 2 is 14g. So that's how we do it, just squared. This one right here, not a perfect square. So this one is prime or unfactorable. Let's move on to this one. Perfect square, perfect square. So 2d and 1. 2d times 1 is 2d times 2 is 40. So that works. Remember subtraction if it's subtraction there. Both perfect squares. 3n times 5 is 15n times 2 is 30n. So that works. Okay, now we're going to factor these, and they could be different kinds. They might be perfect square trinomials, they might be difference of perfect squares, or they could just be trinomials that we factor one of those old-fashioned ways. So let's take a look. First thing here I see is they have a greatest common factor, which is 2. So we always have to take greatest common factor out first. So we're left with x squared minus 36. This is the difference of perfect squares. So it's 2 times x plus 6, x minus 6. Okay, this one, 6b squared is not a perfect square, and either is 3. We can look to see if we can factor it the regular way. So it would have to multiply to be 18 and add to be 11. That works, 9 and 2. So this would be b plus 9, b plus 2. Over here, these are both perfect squares. Oh, no, we got to take something out first. We're going to take a 4 out. We're left with 9t squared minus 6t plus 1. Perfect square, perfect square. So that would be 3t minus 1. 3t times 1 is 3t times 2 is negative 6t. So 4, and then we have to square that. 4 times 3t minus 1 squared. So always take out greatest common factor first. So we're going to take a 4 out of here. We're left with h squared minus, let's see, 14. Yes, 14. We cannot go any further than that. 14 is not a perfect square. Here we cannot take anything out as far as this isn't perfect square. There's no greatest common factor except for a. So we'll take a out. We're left with 17a, because that's a squared, minus 24b. And that is all we can do for that one. This is perfect square by perfect square, and that's a perfect square. But if we take q times 9, q times 9 is 9q times 2 is 18q. So that does not work for that one. So let's go and try to do it the regular way. So it needs to multiply to be 36, and it needs to add to be 14. So factors of 36 are 136. We add those, it would be 37. 218, if we add those, it would be 20. Oh, and these would both be negative, so still adding them. Negative 3, negative 6 would be negative 9. And negative 4. Negative 9 would be negative 13. So those are all the factors. So this is prime. It is unfactorable.